So yesterday we were talking about the factors affecting temperature of a place. We also spoke about temperature in a little more detail, and we are looking at the first factor, which is latitude, and then we saw how altitude changes temperature, and then it was distance from the sea, where I introduced the fact of high pressure and low pressure, and from that we move on to pressure belts. So before I go on to details for pressure belts, what I've done here is to give you an introduction as to what do you mean by atmospheric pressure. It's very important for us to understand that. And then we'll go on to talking about the pressure belts and how they result in the wind systems, and how as a whole then they affect the climate of a place. Okay, so atmospheric pressure, we'll do the definition, measurement, types, causes and effects. In generally, we'll talk about the whole thing. Right. So definition is very simple. It is just the weight of the atmosphere on a unit area of the land. So we know that because of gravity, the atmosphere actually rests on the land. Okay. And therefore, you can calculate that weight as a column of air contained in a unit area from mean sea level to the top of the atmosphere. So what we have actually done is to calculate the weight. We have people initially use what is known as a mercury barometer, which was a tub of mercury, into which 1 meter long glass cylindrical cylinder was heated up so that the air is disappears from it, and it's more or less a vacuum, and then immediately it is immersed into the mercury. So since there is less air inside, the weight of the air rests on the mercury in the tub and pushes the mercury up into the tube. So by doing this experiment several times, they noticed that there was one average weight of 76 millimeters. Okay, 76 centimeters. And this 76 centimeters of air was actually at sea level. Then when they continued with the experiment going to other places, they found that at higher altitudes, the amount of pressure of that air was less. And and in some places in the world, the pressure was more even at sea level. So looking at all this, we generally have what we call the formation of that instrument is called as a barometer. Today, of course, we don't use the tub of mercury and that 1 meter long uh, uh, cylinder, but we just use a similar process that gets the weight of the atmosphere, is sensitive to it, and then it moves and as a like a meter, like a clock, and then it gives you the air pressure. So basically, it is expressed in millibars. So that is known as 1 bar and a millibar. So units of millibar is how you express it. So that 76 centimeters then works out to 1013.2 millibars. So this is one number that you need to remember, because it may come in the examination also, and as a statement that you need to identify as true or false, or even the value itself you need to understand, right? So the average atmospheric pressure is 1013.2 millibars, and due to gravity, you'll find that since the air is denser, it has a higher surface pressure, especially at the sea level, and as you go up, the air pressure decreases. So if there is a value that is greater than 1013.2, then that is equal. That means that the air pressure is more. If the value is less than 1013.2, that means the air pressure is less, right? And that can happen mainly due to temperature conditions. Okay, right. So this is how pressure decreases as you go from ground level above. As you can see, the molecules of air are less, and therefore less molecules means that you have less air pressure, right? Again, here you can see in a contained area, in a small zone, how you find that air pressure is more at lower levels, and as you go up, the air pressure decreases. Sorry, I went back. Now, so what are the properties here? So here the vertical variation of pressure decreases with height, and it is supposed to be at the rate of 1 millibar for every 10 meters. So as you go up higher at 10 to 10 meters in height, you will find that the air pressure decreases. Now, I don't know how many of you have stayed in Bangalore for good, or some of you that have moved to Bangalore, okay, from the plains, from the low-lying areas. Then you may find, except from Delhi or from the coastal areas, when you come to Bangalore, initially people find that they have a difficulty, they have a headache, they have nose bleeds, and so on and so forth. So the height of Bangalore is about 900 meters. So can you imagine how much there is, how less the air is here? Which is why as soon as the sun sets, immediately Bangalore cools down. Whereas if you go to Chennai, even after sunset, it is still very, very hot. The reason is there is more air, and more air takes longer to cool down when compared to less air. So that is why the higher you go, temperatures drop very quickly. Temperatures may also increase also similarly, but mainly it will drop very quickly because there is less air. And it may, for some people, it may create problems. Even this 800 meters may be, because we're used to living at almost 3 meters, 4 meters above sea level, then a jump of so many meters definitely makes a difference to you, right? Now, this rate of decrease will not be at the same rate because we know that temperature is the one that is causing it. So if temperatures are increasing rapidly, then the pressure will drop actually very quickly. And if the temperatures are increasing slowly, it will drop slowly. So that's what I said. Just not pressure of a place is affected by the temperature, right? So here is why we are having it. Like I told you yesterday, that when air becomes hot, it generally rises up. So when there is rising up, you'll find at the ground level there is less air, and that's how we have a low pressure created on the ground, right? Now, if you look at the air pressure right across the entire atmosphere, right, you will find that the pressure is just constant. It's not like the temperature graph where you have a zigzag, right? But here you will find that it just decreases because obviously the amount of air at very high levels is almost equal to zero, right? Air is more like molecules rather, I mean, and different separate molecules rather than mixtures and so on. And therefore, you'll find the amount of air is much less. But in that little air also plays a very important role in our lives. Like we saw yesterday how we have radio waves, how we have the aurora australis and borealis and so on. So this is what happens here. We have cold air, and then we have how the warm, cold air rises up. Sorry, I think that's a mistake here. Yeah, so here is where you have low pressure on the ground, warm air rising up, okay, and you have low pressure in the ground. Now, as you can see on the other side, either side, you have cooler surroundings. So when you have cooler surroundings, what will happen is that the air pressure is higher there, and therefore air will move from the cooler surrounding into the warmer surrounding. And that is how you have a decrease in temperature, right? Cold air generally just tends to sit on the ground, and therefore you will have a continuous cold temperature. The temperature also will be low only, right? And they will be, because there is high pressure on the ground, there is no way in which any air from the surrounding region can come in, right? And it always almost stays on the ground at whichever level, whether you are cold air in the Himalayas or cold air in the plateau region or in the plains, okay, right? So it creates a higher pressure. So here is where in the equatorial region, it is always hot, like we saw it earlier. So in the equatorial region, air is always rising. And therefore, we have a situation where we always have a low pressure area around the equator. But in the polar region, you'll find that air is actually, it's cold there. So air is always settling down. And therefore, you'll find you have a high pressure zone, right? And is there any connection between the two? So you can see, so tropical region is warm, you have low pressure below, you will have a high pressure above. And then in the polar region, it is high pressure on the ground and you have less air above, right? So this is with explaining or describing the places in these particular areas, in the equatorial regions, or let us say even in the entire tropical region. and in the entire polar region, which is the frigid zone. Okay, right. So one more thing that we need to understand is that when the air is at the ground level, it is always warm and moist. Okay, so this warm, moist air, when it rises up, you will find that not only will it lose its temperature and become cold. Now, why does it become cold? Because it is spreading out, because it is going outwards into a greater surface area, right? And as it goes into a greater surface area, naturally the frictional heat is lost and the temperature comes down. And there is less air also, but let us say a parcel of air is rising up and that air then spreads out. So the moment it spreads out, it cools down. Now, in the process of cooling down, if the warm air has got moisture in it, generally warm air always will have moisture in it, because warm air, warmth itself will create evaporation. So as it rises up, you will find it will drop all the moisture. So somewhere around 2000, 3000 meters above the ground, or above the place from which it is rising up, generally it will condense, form clouds, and then it will rain. Okay. And then it may continue to rise up. Now, why does it continue to rise up? Is because warm air is continuing to rise up from below. And so it pushes up. So it has that push from below. And as it continues to rise up, maybe to about 6,000 meters or 6 kilometers, you'll find it not only becomes very cold, it also becomes very dry. Now, this cold and dry air, because it is cold, now it is also becoming heavier. It then moves sideways, right? In a process is what we called as advection in the upper troposphere, and then it begins to come down in a place where there is no rising air. Where the air is not rising, this cold air comes down. So when it comes down, it is cold and it is dry. And as it comes down, you will find that it becomes warmer because it is coming from a rare area into a congested area. So that the temperature increases, right? And it increases at the rate of 10 degrees Celsius. We saw that it was 6.6 is the normal lapse rate, but here we have a parcel of air, and so we call it what we call it as an adiabatic lapse rate. Now, you don't really need to know adiabatic lapse rates in your prelims, but just to have an idea as to why when air is descending, right, it increases in temperature. So that's the property, that when air rises, it decreases in temperature by 10 degrees Celsius as long as it is dry. And then once it becomes moist and it has water in it, not water vapor, but water droplets, then you will find that it loses its heat, right? And that heat then you will find it decreases the adiabatic lapse rate. Okay, and it's around 5 to 6. But when air comes down, it is increasing in temperature. And I told you yesterday how at 45 minus 45 degrees over the polar region in the upper atmosphere, when the air is coming down, it reaches about minus 10 degrees, right? Especially in summer. And therefore, that temperature is supposed to be standard temperature. But because of global heating and warmer air rising up, you'll find that it is going to close to zero, and that is why the polar ice cap is melting, right? So this is important for us to know when we talk about global warming. So as we progress and I show you more slides and pictures, we'll explain, you'll understand global warming even better. Okay, right. So this is the effects of the differences in air pressure. Now, when the warm air is rising up and a low pressure is created, and the air from somewhere else is coming down around it or close to it, then now we have a ground movement of air. So air is moving, excuse me, air is moving from a high pressure area to a low pressure area, right? So then again, the sun rises again and again the pressure. So this is one continuous cycle that we have right across the world, okay? And that is the air that is moving from the ground is called as wind. The air that moves in the upper atmosphere is called as an advection current. Of course, it's not really relevant to you now at the prelims level, but if you study optional geography, then you need to know all this, right? So the difference in air pressure here, therefore, is creating what we call as a pressure gradient, right? And the pressure gradient then results in the movement of air from high pressure to low pressure, and that movement is wind. So pressure gradient is a force that is very important, right? That helps the development of wind. Remember, if you did not have this, then the entire condition of our earth would have been totally different. The equatorial regions would continue to be very, very hot, okay? And the polar regions would be icy cold, much colder than they are now. But because we have this various high pressure and low pressure areas, right, we have what is created as a pressure gradient force. And that's why we have movement of the this thing, what you call air, from one place to another. And this air then it's supposed to eliminate pressure differences. But of course, since the sun is ruling here, so therefore the pressure differences are never eliminated, and therefore the air continues to blow, right? So it blows basically from high pressure to low pressure, and we'll see it in the world picture also. And it is also important that if the high pressure gradient is very strong, the speed of the wind will also be very strong. So for the pressure gradient to be very strong, the high pressure they should be and the low pressure should be extreme in both. So from very high pressure to very low pressure, they should be pretty close to each other, and that is when you have a strong wind blowing. So that is what happens in a cyclone. In a cyclone, it is like a small cell of low pressure surrounded by high pressure, and the pressure increases very fast from the center, and that is why the speed of the wind therefore also increases. Okay, so that's your pressure gradient force. So stronger the pressure gradient force, stronger the wind. That's just in general information. Yeah. Then, if there are no other forces, then you will find that there are other forces in play here that are affecting what we call as not only the velocity but the direction of the wind. So, if there are no other forces, then you'll find wind will normally blow only from high pressure straight directly to low pressure, but that is not what is happening. Except for land and sea breezes. Land and sea breezes, it is happening in less than 24 hours in a very short period of time, and therefore you will find that the wind complete just comes in straight, right? So if you're standing, depends of course in the season also. In India the season also affects the direction of the wind to some extent, but land and sea breeze actually comes straight in and straight out because it is a localized condition and there are no other forces that are at play here, right? But when the northeast monsoon is blowing or when the southwest monsoon is blowing, that affects the wind direction of the land and sea breeze, but only in India, not anywhere else. Okay, right. So that's your pressure gradient, a direct one from high pressure to low pressure, and no other forces are affecting it. So let's now look at the bigger picture, which is the world pressure belts. So the world pressure belts here, the formation and the effects of the world pressure belt. So then we have understood here how lows and highs are formed and how you have the movement of air going from warmer to lower to colder and colder to warmer, right? So let's first look at the starting point here is the equator. So the sun's rays are vertical here. Temperatures are high. Ground gets heated up very quickly. Therefore, the air that is resting on it also gets heated up. Now, the air gets heated up by three processes. One, the first process is just conduction. Conduction, as you know, is the rising of temperature due to the contact of the air over the ground. And then once the lower levels of the air becomes hot, then the next process starts, and that's the process of convection. Then we also have the process of radiation, because anything that becomes hot will radiate out the heat. So if you, for example, if you have a hot water in front of you vessel, excuse me, I have a small sore throat today, so you'll be disturbed a bit. So when you have anything gets hot, immediately you can feel the heat. right? And that is called radiation. Then the air around it gets hot, and that air then begins to heat up through the process of convection. So both liquids and gases heat up through the process of convection, right? So convection, what does convection mean? That you have rising hot air and the cold air sinks below it. Again, cold air comes into contact with the ground, which is still hot, becomes hot and rises up. And this is a kind of a circular process and it's a very slow process, right? And that's how you will find you have this. Now, in the equatorial low, the rays of the sun are vertical at midday throughout the year, 365 days. And therefore, you will find you have a permanent low pressure. And that permanent low pressure is called as an equatorial low. And the air that is coming from either side is called as a convergent air. And this air actually is a form of a wind that you will learn about a little later. Then what happens to this air? So initially it's become warm, and it in many cases the wind is blowing in from the sea. So it is bringing with it a whole lot of moisture. And this warm moist air then begins to rise. And as I told you earlier in the class, it rises and then you have condensation. So what is condensation? Condensation is water vapor turning back into water droplets by the process of cooling. So cooling converts the water vapor back into water, and then you have the formation of clouds. And then once a cloud is formed, so a cloud can form up to a maximum of 10 kilometers, 8 to 10 kilometers above the Earth's surface. And these clouds have special names. They are called as cumulonimbus clouds. They start from about 2000 meters and go up to 10,000 meters. So here is where they are really very large, and they are like they disappear also very fast, right? They form very quickly and they disappear very quickly. And this is what gives the equatorial region their heavy rainfall. So as this cooling and expansion continues, like I said, this air is rising all the time. And as it rises every day, so it has been able to reach about this 8 kilometers within the day. Like starting at 10 o'clock in the morning, probably the air will start rising. By 2, 3 o'clock, 4 o'clock, it's already reached that because it's very hot and it's very light and is rising up. But after that, it begins to slow down, right? And it continues to rise because it's still warm and moist, right? And it lost its moisture a little bit, but it's still warm and it continues to rise. By the time it has reached about the top of the atmosphere, it takes almost 15 days. But by then, the next day, the sun has risen, ground has become hot, air has become hot, and then the air rises. So there is a continuous like supply of warm air from below, and that is why you will find are you able to sorry about that disruption there. Right. So then the cold air is, the cold air on top is, it is cold and dry. So every day this is happening, and every day we have cold and dry air. So what happens to this cold and dry air? Now, cold and dry air, especially because it is cold, will come down because of gravity. And as it comes down, where does it come down? Right? So it is pushed on either side of the equator because it can't rise up and go away beyond that. And it comes down over 30 degrees north and south latitude. Like I told you earlier, when it comes down, you'll find that it becomes warm and it continues to remain dry. And now we have a situation where at this area on around 30 degrees north and south, we have a high pressure zone. And that high pressure zone is called as the subtropical high pressure zone. Okay, so we have an equatorial low in the center. It should be low by mistake. I think I put high there. It should be an equatorial low in the center, surrounded by the subtropical high. So when you have a low and a high, then obviously air is going to move from high to low, right? And that is the air that is coming down. So it normally goes over the sea because that's the pattern that you can see in the world map, right? So when it crosses the sea, and also for another reason, it then picks up the moisture, right? And then it brings rainfall to central parts of northern parts of North America, central parts of Africa, and Southeast Asia, right? And that's the equatorial climate. So this is now this movement of air. So again, then the air is rising up, and then you have it becomes cold and dry, and then comes down. So this circulation of air is then called as the Hadley cells, right? So within the tropics, the movement of air from ground to the upper troposphere, back to the ground, and then blowing as a wind, and then again going up over the equatorial region, right? Then there is one more alphabet here, ITCZ. So ITCZ stands for Intertropical Convergence Zone. So within the tropics, we have air, warm air that is converging, right? And that is called as the ITCZ. Now, the ITCZ is very important for us here in India because it is what causes India to have the monsoon climate. So monsoon climate happens only because the ITCZ moves into India and then brings in the wind system and gives rain to all over India, especially up to the foothills of the Himalayas, right? And that is the importance of the ITCZ. But we will do that later. Okay. Now let us just look at what happens in the subtropical high pressure zones. So we see all these regions. You see they are all deserts, right? Don't look at Gobi Desert and Karakoram. Only look at the line latitude 30° north and 30° south. These are the important deserts of our country, of our world, which are known as the hot deserts, right? So in North America, it's called as the Sonoran Desert, okay, or the Chihuahuan Desert. Then you have Sahara in Africa. Then you have the Arabian, and then in India, it's the Thar Desert. Okay. Then if you go down to the southern hemisphere, in South America, you have the Atacama Desert, which is the hottest and the driest desert in the world. Then you have the Namib and Kalahari deserts in South Africa. And then you have the great whole of West Australia as a desert, right? The Great Sandy, Simpson, there are many names there, Victoria and so on in Australia. So this is the reason why we have deserts in the world, because these are areas from where the air is coming down from the upper troposphere, from cold and dry and becoming hot and dry, right? And that is where you have all the deserts. So this list of deserts is important for you to know. Very briefly, let me just tell you that the other deserts, the Gobi, the Karakum Desert, and so on, Thar Desert should be a little lower. It's a bit high here, right? It should be a little lower because it's exactly, in the northwestern part of India. So it should come down a bit. But other deserts here are deserts because they are far away. That Great Basin Desert is and Karakum, and they are far away from the influence of the sea, and the winds don't bring rain, and therefore they are dry, and that is why they are deserts, right? And in this case, it's very hot in summer and it's very cold in winter. But Sahara Desert and all, they are not very cold in winter. There's a huge difference between summer and winter. Daytime temperature in summer and night and day temperatures. But summer and winter, it's not very cold like Sahara Desert. And would also have another factor. Arabian Desert is a little more cold because it is at a height, because it's an Arabian plateau. Same way with Sahara Desert is also a plateau. But Thar Desert is in the plains. And so Thar Desert reaches 55 degrees Celsius in summer, whereas the other Sahara Desert and all will not be about 40, 45, it will not be very hot. But it is very dry, right? And because it is very dry, you feel the heat of the sun. That's as simple as that, right? Okay, so this is the formation of highs with reference to, and the formation of deserts, especially with reference to the formation of the high pressure cells. Okay, so when you have a high pressure, very simply, you will find that the sky is clear, air is coming down, and therefore the air pressure increases. And because it is coming down and it is dry, and it is increasing temperature, it becomes drier, right? And during the day, it will be very hot. At night, it will be very cold, right? Or it will be low temperatures generally. Then it's very calm. You don't have much of uh, winds blowing in this region. So it's extremely calm, except in summer when you may have a whole lot of. One second, let me just attach the. Sorry. Okay. So you may have what we call as dust storms here, because you have local low pressures created. Remember, the question in your mind should be that if the temperatures are so high in summer, then wouldn't the air rise up? Yes, it does rise up, and it creates a local low pressure, just like your low pressure over the land in places, in coastal places. So low pressures are created here, and by afternoon, because the surrounding region you may have higher pressure, air will move from high pressure to low pressure, and you will have a very big storm. Unfortunately, the surrounding region is completely dry. It's made up of sand, right, and small stones and so on, and all that is lifted up, and that's how you have sandstorms in this region, right? So wherever you have sandy deserts, you have lots of sandstorms right through summer, and then in the winter it just settles down, because in winter the temperatures drop a bit, right? So you, at night, day and night, you may also have the formation of frost. You may have thunderstorms. You have snow in winter if it's very high. The uh, if the desert is a higher desert, like the Mojave Desert, then you may have snow in winter. Right. So we studied, understand, I think, the formation of lows, right, and how you have the lifting of the wind. So if you look at the entire world now, you will find that you have alternatively high, low, right? So we have understood how the equatorial low is caused, and then the Hadley cell is caused by the advection of the rising air from the equator, and it coming down and sinking towards 30 degrees north latitude, and then moving sideways, right, into towards the equator. Now, at 30 degrees north again, or rather at 60 degrees north, the story is different. Now, the 60-degree north latitude is a smaller area, and because of the speed of rotation, you will find that air is lifted off the ground. There is displacement of air. So the moment the air is, and the air is, Earth is going to rotate continuously. So here is where, because of the displacement of air, then the air from the subtropical high also moves towards this zone, which is called as the subpolar low. Okay, sorry, this is primary radius, right? So the subpolar low here, as the name shown there, is created because the air is pushed up because of the rotation of the earth, and when it is pushed up, it is just forced to rise up. And as it rises up, it cools. And when it cools, it becomes dry, but it cannot come down in the same place. So what happens? It gets separated. It separates out into two parts. And one of it goes towards the subtropical high pressure zone. And one of it goes towards the polar zone. And that is the air supply for the polar zone. So air will go up to the polar zone and then begin to settle down. As it settles down, starting at minus 45 degrees, it then reaches 10 degrees Celsius. And then, since there is a low pressure nearby, air moves out of the polar region towards the subpolar region, right? And the circulation is continued. So the air that is moving from the subpolar region to the subtropical high, and then it then comes back towards the polar region because there is a low pressure there. That is called as the Ferrel cell. Okay, so we have Hadley cell, right? We have Ferrel cell and we have polar cell. So in the order as going from the equator towards north or towards the south, right? This is the order. It's Hadley cell, Ferrel cell, and then polar cell. Okay, and this is what we talk about, as the impact of, or the meaning of global warming. So when I am burning something over the equator, okay, or even in the tropical region, say I'm burning my garbage, or I'm burning my agricultural crops, right? So the air, the hotter air is climbing up, and the hotter the air is, the less cool it is going to be there, up there at around 8 to 10 kilometers. And when it is less cool and it is coming down, then the temperatures are going to be higher when it reaches the ground. That's your Hadley cell. Some of that air also reaches the polar region, okay? Because the Earth is a ball, so some of that air also reaches there. But let's concentrate today only, I mean now only on the the subpolar region. What is this 60-degree north? These are all the developed countries in the world. The whole of Europe, European Russia, as well as USA, North America, right? And that developed country is generating much higher temperature because of the use of transportation, because of the use of fuels, fossil fuels in a large number. And therefore, they are the ones responsible for the melting of the ice, right? So in the southern hemisphere, it is the countries of Africa. Africa is always burning things. One, two, South Africa especially, and then Australia. Australia is a very developed country. New Zealand is a very developed country. Everybody owns two cars. So if I have a 4 million population, I may have a small population, but I have double the number of cars. And then not only double number of cars, but also many other types of vehicles that are bringing in material and taking it out and so on. So there's a lot of use of fossil fuels. And because of this, circulation that we have in the atmosphere, that is the reason why the polar ice caps are melting, right? So it is imperative that they realize that they have to bring down the amount. That is why they are going in more for electric vehicles and so on and so forth, hoping that the emissions would be less, right? Carbon dioxide emissions. Carbon dioxide is most popular. Apart from that, we also have other gases. So that creates a very big problem there. But electric cars, unless they are created by low emissions of carbon dioxide fuel. Like for example, natural gas. Natural gas does not produce that much of carbon dioxide. So most of UK and parts of France and all are all using natural gas to generate electricity. So if we turn to electric cars, maybe the problem will be solved. But like I said, the problem is not really only that. The problem is the loss of tree cover. All these areas were completely covered by forests. Now they have been completely covered by buildings. So we have what we call as a concrete jungle here, right? And we have black roads, which increase the heat because black is has the ability to take in more heat and release more heat, right? So we need to change. There are many rules now in these areas where they are doing using white cement, concrete, and so on and so forth. But then there is steel on the roads, there's steel in the bridges. All that is adding to the heat of the atmosphere at ground level. So when this ground level heat is rising up, it is going to definitely cause a problem. So that is one of the things that is happening here. Now we must also remember one more thing, that the entire world or the earth has been affected by what we called as global warming and ice ages alternatively, right? Now, what is the reason for the ice age in the past is mainly because of volcanic eruptions. So when you have many volcanoes erupting left, right, and center, lot of ash is thrown up in the atmosphere. When lot of ash is thrown up, it will block the light of the sun and the temperatures come down. So that's what's been happening. But as soon as man started development, the process of global warming has speeded up. So global warming actually started about 25,000 years ago. But in the period when we had the development of fossil fuel and the development of transport, that is when we find that the global and industrial activities and so on, that is when we find that the situation has become much more complex and much more like it has become very, very fast. And is there anything we can do to slow it down? Not really. It'll take another 100 years for it to slow. Once you start something off in the atmosphere will take its own time to adjust and this thing to the new conditions. So tomorrow, if I say all vehicles will stop on the road and we are not going to have any vehicles and no industries at all, which is an impossible thing, then you'll find the atmosphere will take time. Which is why during the lockdown period, in the month of March, May, it was still pretty hot, but by May, temperatures had actually come down in Bangalore. The reason being there was no traffic on the roads for so many days, months, right? And that is why no formation of greenhouse gases, and that is why you'll find that that can make a difference. But at the same time, we need our tree cover, right? Singapore is planning, has been growing trees on top of every building, making green buildings and so on and so forth. And they have lost their forest cover completely. It's no longer equatorial type. It's Indian type of climate, I would say. It's because they brought in Indian trees there rather than growing back the original trees. It's beautified and so on, but the trees there are small leaf trees, and if you have small leaf trees, the transpiration also will be less, and therefore the rainfall will be less. So they made an error there because they probably didn't know better. And like I said, our planning department does not know the geography, where you study many aspects of science, right? And that's how it is. So this is the concept of this. Now, what we also have here is that when the wind is blowing, so now we have the wind blowing towards this region. So when the wind is blowing from a warmer region to then it will increase the temperature, right? And when the wind is coming from a colder region, it will decrease the temperature, right? So that is the effect of pressure belts. Indirectly, it is the wind that is causing a difference in pressure, except for in the polar region and subtropical regions where it is descending air, and in other regions it is the wind that brings the cooler. So moment the wind blow, the temperature drops, especially if it is coming from a cooler region. But it's coming from a hot region, like for example in the month of May, in and around Delhi, Punjab, Haryana, North Gujarat, the temperatures rise very rapidly because we have a hot wind blowing out from the desert, from the Thar desert, known as the Lu winds, right? And these Lu winds increase the temperature and not only and completely dry you up. Even if you are in a Lu wind, then you can expect your whole body to get dehydrated, which is why then they say you stay out of the sun, you stay in the shade, or you keep sipping water. That is the only way you can, help yourself to remain, hydrated and not fall sick, right? So these are all these conditions with reference to, right. So this is called as a trimeridional cell, and this slide shows you what happens to the climate. So the climate in the IT season or equatorial region, all season it is wet. But that is no longer true because the natural vegetation has been destroyed. So Southeast Asia, Malaysia, Singapore do not get rainfall throughout the year anymore. They get rainfall only when the winds begin to blow in, and that is for a different reason. And so then, but it's supposed to be all. That is why we had the huge Amazon forest. But then they cut down 80% of it. And now that they've cut down the trees, the rainfall has decreased. Congo is going the same way, but it is not going at the same speed as Brazil. So the Congo area, right? But unfortunately, there also trees are being cut down, right? So trees play a very important role there. Then in between zone is a wet and dry climate, which is India. India is a wet and dry climate. Then you have all seasons dry. That's a desert. That has not changed. Rainfall has not increased in the desert areas, right? Only you have some storms coming in, which are very rare, but otherwise it's been completely dry. Then you have, as you go further north, you have a dry summer and wet winter. That's a Mediterranean type of climate. Then you have the entire region being wet, up to 60 degrees north. You have all seasons wet. It rains throughout the year. It snows in winter. That's most of Europe and also North America, right? And then you have all seasons dry in the polar region. So you can see how the formation of lows and highs actually have a direct impact on the climate of a place. Right. And this is the big picture in the world of what is happening, right? In places how the air pressure is rising. And then they've also given you what are the forests that you have. You have the equatorial forests there. You have the deserts over 30 degrees north and south, northern hemisphere, southern hemisphere. And as you go further, you have some more stormy regions because there's the meeting of hot air and cold air. And so you have the formation of cyclones there, known as temperate cyclones. Excuse me. Okay, and that's the picture of the world. So when we talk about decision making, we always need to look at the bigger picture. We can't just say look at a smaller picture. For example, I remember Kapil Sibal made a statement saying that it is rubbish about rubbishing global warming, and saying that the Himalayan ice glaciers are not melting. Now, in that particular period, 4 or 5 year period, we had a suitable temperature and everything, so the length of the glaciers was just the same. But we cannot look at 4 or 5 years. We need to look back at what it was 100, 200 years ago, and then we need to also see in between, after the period, what's happening. So in between, we have had global warming, and we've had the glaciers receding because they are it's warmer and therefore they are melting, and we need to look at that. So recently, last year we had, not last year, this year only, we had that in the Himachal Uttarakhand region, how you have Uttarakhand region where you had the glacial melt, and one lake overflowed, and the broke the bridge. It broke this thing center there, generating hydroelectric power. Everything it's smashed up. So the reason is not just that it is not only global warming. We need to know when a glacier melts, what is it that it's carrying also, because a glacier carries huge rocks with it. It's not just water, it's also rocks. Okay. So, and these things can happen. We because the weight of the glacier, the inside of the glacier is still watery, is still liquid because of the weight, right? Because you know that as the weight increases, temperature increases, and temperature increases, then the water will not freeze. So very simple. These are facts that we need to look at the bigger picture, right? And understand that better. Right. So that again here of the what is happening. That's a general picture that you can probably take a screenshot, or you can just take a picture, and this gives you the whole picture of what I have talked about today. And you can attach many concept questions to this particular diagram, which are very relevant not only for just temperature and climate, but also for global warming. Okay, right. So we also need to understand about the wind system. So when we talk about the wind system, we have many types of winds. But in the beginning, we begin, because I'm talking about the pressure belts of the world. So I will focus on the formation of what we call as the planetary winds, also known as the prevailing winds, and how they are named, how and why they are named so. Okay, right. So first, we already understand that important forces that are affecting velocity and direction of wind. One is the difference in atmospheric pressure. So atmospheric pressure affects the velocity of the winds, not the direction. Air in motion is called wind. Wind blows from high pressure to low pressure. Now we also have the rotation of the earth that affects the wind movement, and that is the wind direction. Okay, and that is called as the Coriolis force. So the rotation of the earth creates what is called as the Coriolis. So if you look at factors affecting wind, one is the PGA, the pressure gradient, then the Coriolis force, and then we have the frictional force. Frictional force is just the impact of the uh, winds, when the winds are blowing on the ground, on the surfaces, right, which may slow down the wind actually. And in addition, we also have a gravitational force that causes the wind to hit downwards, right? And therefore it comes in at an angle, right? And that is what creates waves. So waves in the sea are created mainly because of this gravitational force of the wind hitting downwards. Okay, so these are the four factors that you just generally need to know. Pressure gradient, we have already talked about. Frictional force is not important. What is important? Yeah, so we've done this, right? Is these are other information about the pressure gradient. One, that it is perpendicular to an isobar. Isobar are lines drawn on the map joining places having the same air pressure on the ground. I'll show you the map in a bit. Yeah, same atmospheric pressure brought down to sea level actually. Then the higher the pressure gradient, the higher the velocity. We've understood that. The greater the velocity, the greater the deflection caused by Coriolis force, right? And at the equator, Coriolis force is zero because it is the broadest part of the earth, and therefore it is zero. So 0 degree latitude, and therefore 0 degree of zero, Coriolis force. So the wind direction is there, it doesn't have a fixed direction, right? And the wind, yeah, blows forward. So here is where you have the map of the world. So these lines that you see, they're all in millibars, and that is sorry, in these are all temperature lines. Sorry, these are all temperature lines, and the isobar runs parallel to the temperature lines, right? So here, these are what are called as isobars, okay? And you can also call them as isotherms also, right? And that's what it looks like. So that results in high pressure, low pressure, right across the world. Now, it would depend upon the season, because like we talked about it yesterday, water heats up slowly, cools down slowly. So in summer, you will have low pressure over the oceans and you will have high pressure over the sea. So summer in the northern hemisphere, you have a low pressure. This is the winter condition here, right? No, this is the summer condition, where in the northern hemisphere, you have a high pressure over the sea and over the low pressure. I think they have consolidated it. In January, yes. This is in January, winter conditions, right? And so that's how you have it. So on the land, when you have low pressure, then the sea is automatically high pressure. So air will always move from high pressure to low pressure, right? And this is how we call them as air pressure cells that are created. It's not in a straight line because of the land and water configuration of the earth, and that's why you have circles of high pressure and low pressure. It's not really a belt. I've not showed you that map as yet, but towards the end I'll show you that map, right? We'll show you about the high pressure and low pressure cells, right? So let's look at Coriolis force. So we've gone, I'm just going in what you say, just going according to whatever we have studied so that it's a linked and I'm not doing pieces, right? So we'll talk about the different planetary winds, and then maybe we'll go back to the factors affecting temperature towards the end of this, okay? That is if we have time. Right. So this force was discovered by a French physicist, right, after whom it was named in 1844. Okay. And it causes the deflection of the wind to the right in the northern hemisphere and to the left in the southern hemisphere. Okay. So what does this mean? Is that if I am at the equator and I'm moving towards the North Pole, then if if there is a wind, if I am the wind, I will be pushed to my right. Okay. And if I'm in the southern hemisphere and I'm looking at the South Pole, then I will be pushed to my left. So when the air is moving from one region to another, so everywhere in the northern hemisphere, the wind is always deflected to the right, and everywhere in the southern hemisphere, the wind is always deflected to the left. Okay, I'll show you this thing about it. So when the wind velocity is high, the deflection is stronger because then you can really notice it, otherwise you don't. So here is where objects are deflected, or the wind is deflected to the right in the northern hemisphere and to the left. And let's see if this works. Sometimes it does not work on the PPT screen. So here actually, yes. So here is where the wind is moving. That orange dot that you can see is the high pressure zone, and the black dot is a low pressure. Sorry, high pressure, and this is low pressure. Orange dot is a low pressure. And as the air is moving, the earth is already rotated. So here we need to understand the concept is that the wind takes some time to reach the high pressure to low pressure zone from high pressure. It does not happen at once. It takes some time. In the meantime, the earth is rotating all the time and therefore it misses the target. So that's what they say. If you are shooting a bullet from the 30-degree north towards equatorial low, okay, then by the time your bullet reaches, your target would have gone. So you will have to take into consideration as to how the earth is rotating, and then only you fire that bullet. At close range, you will not have that issue. But in long range, that is what you have. So it appears now, if you see the diagram below, it appears that the wind is deflected. But it is not the wind that is deflected, it is the earth that has rotated. So the wind has started off in that direction and it continues to be pulled because the entire zone is a low pressure zone, right? And therefore it continues to move in that direction and appears to come at an angle, right? So that's how, if you're moving in the northern hemisphere, because now what is the direction of rotation? The direction of rotation is from west to east, right? That is why the sun rises in the east. So when the sun is rising in the east, and therefore you'll find the air is supposed to move, right, from high pressure to low pressure, it is deflected to its right in the northern hemisphere, and same way in the southern hemisphere to its left. Okay, right, so that's your bullet one. So the actual path, intended path, is supposed to be straight. By then rotation happens and you have the deflection and the target moves. But that is still as the low pressure. In this case, the target is moved, but that is still the low pressure zone. That zone has not changed, correct? So therefore the air continues. But it appears that the wind is coming not directly, but coming at an angle, right? And that is the angle that we use to name the winds. Okay, so that's your wind names now. So, sorry, this is how it is deflected. Yeah, so these are some factors that the Coriolis force is directly proportion to the angle of the latitude. So, equator is 0 degrees, and that is why Coriolis force is 0 at the equator. Then it is maximum at the poles, right, which is 90 degrees, right? So that's how it is, how stronger, much stronger it is at the pole. And secondly, it is acts perpendicular to the pressure gradient. Pressure gradient, remember, is a direct path between high pressure and low pressure, right? But the Coriolis force acts perpendicular to it, and therefore the wind is pushed. Okay, so then the wind direction changes. So around the equator, there is no deflection of the wind. There is a wind that blows in the equator. Now it's become stronger because of higher temperatures. That is known as the equatorial westerlies. Otherwise, that region is called as a place of no winds. You may have learned it in school as the doldrums, okay, the belt of calms. So that's why you have no winds there. But you have a wind, that light wind that blows, and that becomes stronger in the summer especially. And it's not good for us in India if it becomes very strong, because that is the El Nino effect. Okay, we'll talk about that later. Right. So then here is where the deflection is more and more. So the deflection is maximum around 60 degrees north, because that is the point from where the winds are moving out of the high pressure zone in the polar region and into the subpolar low. Okay, right. So here are the various names of the winds. So winds that are blowing towards the equator are called as the trade winds. And we also use the words as northeast trades and southeast trades. Then winds that are blowing from subtropical high pressure to subpolar low are known as the westerlies. Southwesterlies in the northern hemisphere, northwesterlies in the southern hemisphere. Then winds that are blowing from the polar high towards the subpolar low are known as the easterlies, coming from an easterly direction. The surface area is less there. It doesn't seem to come from north. So the pressure gradient force PGF will be straight, but the Coriolis force forces the wind not to come straight, but to come in at an angle, right? Remember, the Earth is moving from west to east, right? And that's how the force acts here, and you have the polar easterly. So these are the development of the winds. Okay. How much time do we have? Yeah, that's the rest of the picture that we have of all the terms that I've just mentioned here. Okay, you have the subtropical, you have the equatorial low, which is also known as the doldrums. Then you have the northeast trade winds and the southeast trade winds. I'll give you a short presentation on why these names, why they call these names, right, later, since we are still doing our temperature. So what happens here is that though the subtropical high is hot, by the time it goes across the sea and picks up moisture, right, then you will find, so that winds that are blowing, say, into South America are coming from the Atlantic Ocean, North Atlantic and South Atlantic. So they bring moisture and therefore they cool down a bit, and they bring rain, and rain of course cools down everything, right? So we have that condition there. So northeast trades and southeast trades. Then you have the westerlies, that winds are coming from the subtropical high, again from the Atlantic Ocean towards the Europe, and Europe is a plain there, so the wind goes right in, and it blows throughout the year, since they are planetary winds, and since they blow throughout the year, you find you have rainfall throughout the year there. In summer, it is rain. In winter, it is snow. Then similarly, winds coming from the polar high, when they come, they'll actually be very cold and very dry, because they're coming, it's extremely cold, so no evaporation. But they're coming into a warmer region, and they come into contact with the westerlies. And when that happens, you have your temperate cyclones there. So during the, yeah, that's how it is there. Now you may ask me, why don't they have cyclones throughout the year? The reason is because there is yet another event that is happening, uh, and that is the shifting of the pressure belts because of the revolution of the Earth. Okay, so effect on temperature: hot winds will increase temperatures and vice versa. Cold winds will decrease. Descending air increases in temperature at ground level. Rising air brings in winds, which will definitely decrease the temperature. And with that, I am done. So any questions on this part? Do you have any questions? No questions? I hope you will make make a note and ask the questions accordingly. So we'll just, okay. So let me just go on to the next factor affecting temperatures of a place. Right. So that is, these are ocean currents. Now this is the only thing that does not affect the temperature in India, because India doesn't have any like significant cold current that can decrease the temperature. We are in a warmer latitude, in a warmer region, and the sea is also warm. We have an enclosed sea, so enclosed seas are warmer than the open seas, and therefore our temperature is not really affected so much by what we call as ocean currents. Right. So what are these ocean currents? These are steadily moving streams of water in the ocean, right? And how are they actually created? They can be either warm or cold, depending on where they start from. So obviously in the tropical regions, it is going to be warm, right? And in the polar regions, it is going to be cold. So warm currents that start from the tropical region have a higher temperature and flow towards the polar region. That's generally how it happens, okay? And increases the temperature of these places. So what exactly is happening here? Very briefly, I'm going to do this because this is a different topic. This is oceanography. I'm just going to explain it briefly where I want to explain how these ocean currents are formed. So just like we talked about hot air and cold air and saw how hot air tends to rise up and cold air tends to settle down, we also have the same this thing for what do you call water. So in the polar region, what happens is that the water, surface water becomes very cold and begins to sink, right? Now, if this water in the sea starts to, descend, what will happen? Just like this high pressure zone that we have, the water, when we have a low pressure, the air is moving from high pressure to low pressure. So in the polar regions, when the sea level sinks down like that, you will find that the upper water from the surrounding ocean moves in. And when I say the surrounding ocean, I'm looking at an entire ocean. Okay, so I'll show you the map here. Okay, yeah. So here is where you have red and blue. The red is the warm current and the blue is the cold current. So the currents actually begin the mechanism to begin the currents was in the polar regions. Because in the polar regions, you'll find that because of the cold, the water is sinking. Now, due to gravity, this sinking water begins to, no, sorry, not only because of gravity. Like I said, when the water sinks down, to imagine that you have a tub of water where the uh, bottom of the, when you make, you supposing you sort of incline that tub, fill it up with water and incline it, okay? Then if you put ice in the lower portion, you may actually, or in the higher portion, sorry, in the higher portion, if you put ice, right, without it flowing down, of course, put a slab of ice, then and if you have a small incline, the water will move along the bottom of the tub towards the lower portion of the tub. So the top here is the polar region, and the lower portion is the equatorial regions. Now, when the water is moving, obviously it is going to displace the water in the tropical regions or in the equatorial regions. So the tropical water will move towards the polar region. And this is a simplistic explanation of how ocean currents are created. But you can see here that the water does not seem to be moving straight. For example, I have a warm current which is called as the equatorial current. You all know Atlantic Ocean. Atlantic Ocean is between North and South America and Africa and Europe. Okay. So on there you can see that the currents seem to be going in the corners of the land rather than straight. So if I say the water is sinking here and then it is going there and warm water is going there, it should go directly, right? So the currents also should be direct. But because we have a wind system in place, the wind pushes because the current. So yeah, so I should also say the warm current is formed at the top, okay, flows at the top, and the cold current flows below. All right. So here is where when the wind is blowing, it does not allow the warm current to go straight like above in the northern hemisphere straight to the Arctic region. It pushes it and makes it flow parallel to the equator, and therefore it is then called as the north equatorial current. Now, since it is in the water, when it reaches the land, it is still being pushed by the winds, right? and there is still being pulled by the lesser water there in the Arctic region because the water has settled down, right? And therefore it makes a turn, and then it is called as the Gulf Stream. Okay, so the Gulf Stream is just another term that is called. It's called a stream because it just moves a bit faster. It goes actually into the Gulf of Mexico and then comes out as a Gulf Stream. So this map, this is a generalized map. Then after that, the westerly winds set in. When the westerly winds set in, it pushes the current across North America and it slows down. So therefore, it is called as a North Atlantic drift. So drift means very slow current, stream, and there's only one stream, and that's a faster current. And then that is going straight towards Europe. So what is this water that is going towards Europe? Is basically the North Atlantic warm current, right? And when it goes there and reaches there, especially in winter, so a warm current will also release that heat into the atmosphere, and then it will carry warm air with it. And therefore, this warm air will completely decrease the temperature of coastal Europe, right? Especially northwest Europe, northern parts of Europe, right up to a place called Murmansk in Russia. Okay, Russia just has one or two ports, and Murmansk is one of them. And therefore, you'll find that this warm air and warm current actually brings up the temperature and makes this region completely ice free, which is why you can carry on trade throughout the year from ports in these areas, right? So now that the water has reached there, what has happened to the cold water? Now with this water moving away, naturally the balance of the seawater has to be maintained, so the cold water comes up, and that is called as upwelling. So we have a canary current there, but that current, canary current, has actually been flowing, and it flows due to gravity because gravity is more towards the center of the earth, right? And that's why it is flowing in that direction towards the equatorial region. So around about 10 to 20, 10 degrees north of the equator, the current, then water, cold water that has been flowing underground, under the sea all this time, now because the water has moved away from the tropical region, it has come up, right? And the earth is constantly rotating. The temperatures are almost constant throughout the year. Then we have the winds blowing constantly, and therefore this is a constant occurrence. So throughout the year now, there is a wind current, that warm current that keeps the coast of Europe free of ice because it is a warm current bringing warm air with it, right? So that's how we also have a transfer of heat from the tropical regions to the polar region. So we are maintaining that heat. Just like we have hotter, almost warmer air going towards the polar region, right? Similarly, we also have these other the ocean currents also do a very big job in balancing out the heat so that the hot regions don't become too hot and the cold regions don't become too cold, right? So what does the Canary current do? So Canary current flows along the western coast of Sahara Desert. There's a Canary Islands there, and it continues to remain a desert. So you may think that the Canary current may, because it's cooler, right? Then you may, it may be, because it's cooler, you may have more rain. But I just said that cooler it is, lower rates of condensation. And therefore, the region just remains a desert, but it's a cooler desert, right? Let me take you to another part that is in the Pacific Ocean. On your left, you can see the term Peru there. Yes. So that is the Peru current. The currents are named because depending on the places in which they are flowing. So the Peruvian current is a cold current. Starting off in the Antarctic region, okay, in the Antarctic seas, which is also known as the Southern Ocean, and it then moves underground. And because the warm current, South equatorial current has moved off, it then comes up. near what we call as the Atacama Desert. When it comes up near the Atacama Desert, that area becomes extremely cool. Now, Atacama Desert is at sea level, and therefore the temperatures there are dropped. It's anyway a desert, and then the Peruvian current just does not bring any rainfall at all in this area. And so it continues to be a desert. It is the driest desert in the world, not only because it is in the subtropical high pressure zone, but also because it is affected by this cold current. We have a similar current for Namib and Kalahari Desert in South Africa, and that is the Benguela current. It decreases the temperature of the place, so people can stay there and feel nice, but they have to look for water from under the ground, okay, or rivers flowing from north to south and bringing the water. Like we have the Nile flowing across the desert, and that's why Egypt is able to develop itself, right? Or we have the Indus flowing, or used to flow in, now it is flowing in Pakistan, which is a part of the Thar Desert, right? So unless water comes in from outside the region, these regions actually have hardly any rainfall. They're the driest regions in the world. So in terms of temperature, we find that warm currents moving into a region will increase the temperature. Also, it will increase the rainfall because it is bringing more moisture. Whereas cold currents will decrease the temperature and decrease rainfall also, right? Now I'm giving you a third example, and that is that of Labrador. If you go see Greenland, you have East Greenland, right, and you have Labrador, and it is marked in blue. Now, the Labrador current is a surface current because there is no warm water there, right? The entire sea is cold there, and therefore, because of these movements, this is also pulled towards the south. And when it comes to the south, it actually meets the Gulf Stream there. But that entire area of North America, which is a part of USA and a part of Canada, more Canada than USA, is then actually frozen, especially in winter. So there is no chance of you having ports in that region, right? Commercial ports and all are not possible there because the Labrador current freezes it, and you cannot have the sea freezes, the top of the sea freezes, and so you cannot have any commercial activity there, right? But the temperature there also freezes. So not many people live there. But on the opposite coast of North America, you have the Alaska current, which is a continuation of the North Pacific drift, right? It is a warm current. Again, if you go to the extreme right side, you have the North Equatorial, and then you have the name Kuroshio. So Kuroshio is the warm current flowing along Japan, and it meets a cold current called the Oashio. Oashio freezes the whole of the northern part there, which is Russia, right? And the Japan, of course, is kept warm because of the Kuroshio current. Then it cuts across the ocean, okay, as the North Pacific drift, and then reaches uh, northwest. Sorry, yeah, North America, where it forms the Alaska current. And that is why it has been good for them, because the Alaska current keeps all that region free of ice. So what is Alaska famous for? Any idea what Alaska is famous for? I'm not asked some questions, so you must have gone to sleep. What is Alaska famous for? Does anybody know? You don't know? Okay, it is famous for oil. It has the richest oil fields in the world. North America does not have that many oil fields. And long back, historically in the past, Alaska actually belonged to Canada. And then USA wanted Alaska because the ports are can be well developed there, they thought. And then they bought Alaska for $1, $1 or $10, something like that, right? And then they became multimillionaires because that's where all the oil is. So discovered the oil there, and then they use that oil. They can't bring it into their own country because that part of their country on the west is completely covered by a high mountain range called as the Rockies. So there was difficulty to move that, and that is why they built the Panama Canal. So ships go all around, right, across the Panama Canal, and all the industrial areas are around the Great Lakes there, and all the important cities are also there. That's a demand for petrol, and that is why USA, when they discovered oil in the Gulf countries, decided to go there, and it was cheaper to get oil from the Gulf countries because it was so easily available, easily mineable, easily transported, and that's why we are so dependent on Gulf oil. Of course, after the crisis there and the formation of OPEC, things change, right? So this is the ocean current. Let's look at India. If you can identify India there, it is just the warm current there. Actually, there are some more local currents there, but they are all warm currents. And warm currents, that means they will only increase the temperature, and they will increase the rainfall there, which is why we get good amount of rainfall from the southwest monsoon winds, right? So in terms of places that you need to remember here, which are the places that are affected by the ocean currents? One is Western Europe and Northwestern Europe, where in winter the ports do not freeze. Okay. The second is the Canary current and the Peruvian current, which actually decreases the temperature in the desert. So people can live there, but have to make alternative sources for water. Similarly to your Benguela current in Namib and Kalahari. And also in Western Australia. The only difference in Indian Ocean is that the West Australian current it disappears during the summertime in Australia. In summertime, the wind direction changes, and they have just like we have the southwest monsoon and northeast monsoon, they have the northwest monsoon there, and the northwest monsoon winds pushes the warm water over the current. So in summer, the current disappears and it increases the temperature of the plateau region. In winter, when the entire thing, in winter in the southern hemisphere, which means summer in the northern hemisphere, the entire thing changes, the wind direction changes, and therefore that's when the West Australian current brings down the temperature of Western Australia. So it's not very significant. Okay, so this is just in terms of temperature and also in terms of rainfall. So Peruvian, Canary, Benguela, West Australian current do not give any what do you call benefit of rainfall because they are cold currents. Okay, and all the others, the warm currents will all increase temperature, increase rainfall, right? Because you have higher rates of evaporation. Then Labrador current is also very important because it freezes the most industrial areas that could have been industrialized of Canada especially and parts of northeast USA, but that's just south where the two meet, right? And therefore development cannot happen there. Then you have another effect of ocean currents. Since we are doing it, I'll very briefly tell you, is that wherever you have the meeting of two currents, that is warm and cold, you have a very good fishing ground. So the warm current brings the fish. So when the fish are in the sea and they get caught in the current, they happily swim along the current, right? Now the cold current is flowing along the ocean bed, and therefore it picks up a whole lot of food in terms of plankton, right? Zooplankton, phytoplankton, drags up all that. So the cold current brings the food and the warm current brings the fish. And where the two meet, that becomes a very important fishing ground. So we have two important fishing grounds, one off the coast of USA, which is called as the Grand Banks, and then one is off the coast of Japan, which is just called as this. So here is where you have two currents meeting, Oashio and Kuroshio, right? and there you have the Gulf Stream meeting with Labrador. Okay, and these are important fishing grounds. Now, how do you remember Oashio and Kuroshio? It's quite simple. Because K is for cold, but it is not cold. Okay, K has alphabet, I mean sounds K for cold, but it is not cold. And O for Oashio, O very cold. Okay, so that's one way in which you can remember it. You can make your own ways to remember. So they're just the important ones. But remember, in the exam, they don't give you important points, but they'll give you these statements, a number of such statements, and then ask you this statement is true, that statement is not, and so on and so forth, and you have your choices to make, right? So that's with reference to your ocean currents. Then we come to great mountain barriers. So mountain ranges are supposed to be natural barriers to the air. Now, this one you know that the Himalayas are protecting the cold Arctic air from coming into India, and therefore India is warm, right? And we are really lucky. Now, what is the reason why the Himalayas are able to block the Arctic air? Is because they are east-west ranges. They go from east to west. And that is the reason why they are able to keep that cold. And the highest mountain range is on the outside. We call it the inner Himalayas because they are inside, but they are outside India. Okay, so the outer range, which is the inner Himalayas, or the what we call as Himadri, right, abode of snow, that is what is the highest and does not allow the cold air to enter into India. More important, it does not even have any valleys or anything cutting across. It's one continuous mountain range, especially from starting from the Nepal Himalayas right across. So the cold air is not allowed to enter into India at all. Okay, but if you look at, so that's North America. In North America, the mountains are north-south, right? So very easily the air from the Arctic region just flows into the country, especially in winter, right? This year also they've had the freeze. The air from the Arctic region just blasts, an Arctic blast, and the air just comes out of the Arctic and just goes straight down right up to the warmer parts, which are Florida and so on. Not only that, they are the ones that are responsible for creating all the twisters. The tornadoes that are found in southern part of USA are all created because you have warm air coming in, blowing in from the south, and you have cold, warm and dry, and then you have cold and dry air coming from the north. Both of them meet together and they form this huge cloud, because air, when it's warm, will have some moisture, and they form this huge cloud and form huge pressures of low pressure created and mixed with high pressure, and that's how you have the tornadoes created, right? The cold air actually goes down into the warm air and pushes the warm air up, and then you have a low pressure created because of that, and then you have the turning of the air around very small cells. Of course, it doesn't last very long. It just comes downwards. It destroys everything in its path. Several towns and cities are sorry, there are only towns in these areas, towns and villages, which are completely destroyed in a matter of seconds. That is why every house is made up of wood, and they have a basement where they can be underground till the whole thing passes, right? It'll pick up cows, it'll pick up cars, it'll pick up a whole lot of things, and it creates a lot of problems in this area. So, therefore, mountain arrangement, right, is very important. Let us take southern India. In southern India, we have, yeah, okay. In southern India, we have the Western Ghats. So the Western Ghats have actually created a problem for the rest of India because they block the winds from coming in, and the winds bring rain. So the interior parts of India in the plateau are all having lesser rainfall and are actually very dry, semi-arid dry, like northern parts of Karnataka, southern parts of Maharashtra, and western parts of Telangana. There's a small this thing there where the rainfall is not more than uh, no, 50 degrees, 50 centimeters, sorry, 50 centimeters, right? And they also create other issues like you have the booth winds and so on and so forth, right? I'll talk about that now in a little while. And that is why the Western Ghats, right? They're they're a climatic barrier in terms of rainfall. Himalayas are a climatic barrier in terms of temperature. Also, Himalayas does not allow the monsoon winds to cross, and therefore the monsoon winds is forced to turn towards Rajasthan, and that's how the whole of India gets rain. So Himalayas is more of a climatic barrier, both in terms of rainfall and in terms of temperature, more important temperature. But Western Ghats is more barrier in terms of rainfall, right? And as we know, if the rainfall is less, then the place will be hotter in summer, and the trees will not be have enough leaves on them, and therefore they won't favor rainfall again. So it's like a vicious cycle in such regions, right? So air rising over highlands also cools down places at higher altitudes. But when they come down, they warm up the places. So places that's what's happening in what you call California region in Australia, where from the mountains the cold air at minus 12 degrees Celsius and all then descend down into the valley. And as we just spoke about it, descending air increases in temperature, and anything that is dry, it immediately catches fire and the fires come. So the fires are not created by man, but it has become a problem for man because man has decided to live there, right? And not realizing the geographical problems of that place. And then we make a big noise about fires being created, and and then you have to put it off, and then you have to do all this and do all that. So before you settle down in a place, you just need to know the geography of that place, and not the geography today, tomorrow, yesterday. It is the geography of the last 100 years minimum, okay, before you develop a place for anything. All right, so that's your mountain range. Yeah, so here is where I was explaining to you how that air coming down. So we have the Rocky Mountains, then you have the westerly winds blowing here in America. They go up, they become extremely cold, and cold air is dry, I mean heavy, so it sinks down, and when it sinks down, it creates this condition, right? So this condition is also called as what we call as so the Western Ghats. Oh, I have a picture of that, I've forgotten. And the west coast of North America have this condition. So it's dry in the interior because of the mountain barrier, right? So climate is affected. And temperature will also be affected because it is hot and dry, it becomes warmer in summer, hotter in summer, and it can completely burn away crops. We have a wind there called as the Chinook winds in North America, and they completely destroy crops. It's known as a snow eater, and it can destroy the crops in summer, dry up crops in summer. And the wind that I told you that comes down the mountain into California, that is towards the sea, that is known as Santa Ana. That is known as Santa, local winds. Okay, right. So we come to the end of this, and these are the major factors that are affecting the climate of a place. L for latitude, A for altitude, P for prevailing winds, P for pressure systems, D for distance from the sea, O for ocean currents, and G for great mountain barriers. So these are all the major factors that affect the climate, mainly the temperature, but also the rainfall. In some cases, we have seen it's also the rainfall, where ocean currents are concerned, distance from the sea is concerned, prevailing winds, right, and mountain barriers, they also affect the rainfall of the region, right? So finally, we have some minor factors. So what are these minor factors? First one is aspect of the slope. So what do you mean by aspect of the slope? Is which direction that slope is facing. So if I take the Himalayas, right, the Indian side of the Himalayas are all the warmer sides. Why? Because at around 30 to 35-degree north latitude, which is where the Himalayas are located, 30 to 30 to, yes, approximately 35-degree north, and a little less in Assam and northeastern side. The sun never goes above the Himalayas. The sun is always in the south because the sun stops at 23.5 degrees north latitude and then moves back to equator, right? So here is where we have a situation where the slopes that are facing the south in the northern hemisphere will be warmer than the north, and vice versa in the southern hemisphere. So this is in the southern hemisphere. So north facing slope, which you shift it to the southern hemisphere. So any slope that is facing towards the north, because the sun is always in the north, okay, New Zealand, Australia, South Australia, New Zealand, South Africa, that is southern part of Africa, Republic of South Africa. All the mountains there, the sun will come up to Tropic of Capricorn and stop. And so only the north-facing slope will be warmer, right? So it is vice versa there. So aspect of slopes. In the northern hemisphere, the south-facing slope will be warmer and drier than a north-facing slope, and the southern hemisphere will be just the opposite. And a north-facing slope will also be drier than a south-facing slope. Okay, so north-facing slope in the northern hemisphere, and again vice versa in the southern hemisphere. That is why China and Tibet has a major problem with water, right? Major problem with rivers, because it is the monsoon winds are not allowed to cross that side, right? And you will find that it is extremely cold there. So there is no evaporation, and because it is at an extreme height, right? The southern hemisphere, you will find the warmer slope. So southern hemisphere, there are not many mountains that are facing north. All the mountain ranges there are north-south mountains. So you have the Great Barrier Mountain in Australia, that is north-south, okay? And so you don't have any mountain ranges, but you have some plateaus, high plateaus, like Patagonia Plateau and so on. But anyway, that is dry because it's in the interior, right? But then if you want to planning to settle down in this place, it's very important to know, right, what to expect in terms. So you can't just say, I see a place, I like it, I'll settle down there. No. So people in the past have actually been able to see all these things and settle down accordingly, right? So again, for example, if you take the Vindhya and Satpura range. So Vindhya and Satpura range are cooler in the northern because it is sun never comes there, no sunlight. You only have daylight, right? But the south facing slopes are warmer. So people live north of the Vindhyas, if it is in the small villages, and they plant their crops south of the Vindhyas and Satpuras. The reason being, the crops require sunlight, they require warmth, right? But for them, it is cooler to live in a north slope. So if they see a hill, they can identify that. But that's what you need to know your geography, right? And people do it out of experience. Like people living there for so many centuries, they would have learned, and unfortunately, they don't pass it on. They just feel it's better. But when we are developing an area, we say, oh, this area is not developed, and we just develop it, and we don't take all this into concern. This thing. Similarly, you also find that if your rays in the, mountain is facing towards the west, the western slope will always be warmer than the eastern slope. The reason being that the eastern rising sun is cooler, and it becomes hotter only after the sun crosses the north, the zenith, right? And then it goes towards the west, and when it goes towards the west, it is hotter, right? So along the Western Ghats again, right, you will find that the coastal regions have a higher temperature. when compared to those are the west facing slopes of the Western Ghats than the plateau region, plateau side. Of course, in India, the plateau begins from the Western Ghats. There's a very small area which is mountainous, but otherwise the plateau actually begins from the Western Ghats, from the eastern slopes of the Western Ghats, and then it slopes down towards the east, which is why we have all the major rivers flowing east. That's the slope of the land, right? So here I'd like to make a small this thing saying that if you are looking for a house anywhere south of Tropic of Cancer and where it is always going to be hot throughout the year, then it is best, and if you don't like the cold, then it is best that you take a west facing house. So in Bangalore, for example, Bangalore is at a height. If you don't like the cold in Bangalore, it is better to get your house facing the west, as many windows facing the west, because it will be warmer, right? If you don't like the heat and you always want it to be cold, then you could get an east facing. North and south here will only be applicable to beyond the Tropic of Cancer. Beyond the Tropic of Cancer, a south facing house will keep warmer than a north facing house. So having your house face north, the windows facing north, your doors facing north, means that in winter you just have cold air coming in because we have the northeast monsoon winds blowing. At that time, northeast trade winds. You have cold air descending down from the Himalayas, which will enter your house, and your house will become icy cold, right? So about Vastu, I know Vastu says your house should face east or north or whatever, but I don't believe in Vastu. I believe in geography, right? And it makes more sense. Okay. One more small thing I'd like to mention, which is again just for general knowledge, is that if you're ever lost in a forest in the northern hemisphere and you can't make out which is north, south, east, west, and you can't see the sun, how do you know, which side you should be moving? Is that you look at the tree. If you look at the base of the tree, you will notice one side of the tree will have nothing growing there. No grass, nothing. Whereas the other side of the tree will have a lot of things growing there. And in the northern hemisphere, that is the south. So then you know that that direction is the south. And you keep moving in that direction just by looking at every tree, right? So, and now of course you have GPS, but if there is no range or anything there, you can have a compass also, no doubt. But that's just one of the natural ways of identifying north and south in a region, right? So west facing slope or house will always be warmer than an east facing, right? So that's your explanation in terms of so northern hemisphere, the south facing slope is warmer, north facing is colder. And same way, if you have east and west, that is with reference to north and south. With east and west, you'll find that western slopes will always be warmer than the eastern slopes. Okay, right. The others are minor factors, really minor factors. Dark soils. So dark soils generally absorb more energy from the sun, and therefore they retain the heat. As you know, when you wear black and go out into the sun, you are going to feel hotter, right? And that is mainly because anything dark will absorb the heat, which is why it is a mistake to have tar for our roads, because it is black and it will absorb it. Of course, they have done white topping, but unfortunately the white topping has turned black because there's so much of soot on the roads, right? Burning of fossil fuels is that white topping has become black or dark gray or whatever it is. So, but white topping, of course, is not really a solution that we have. So they will also release more energy in the form of heat waves, and therefore they will increase the temperature of the surrounding region. So the Deccan region, North Deccan especially, it has all dark black soils, and that is why it is warmer, right? And because it is warmer, the little atmosphere the little moisture that you have in the atmosphere is also lost. But fortunately, the soils have the capacity to retain moisture. So if you add little water, then the water is retained in the soil and it cools down a bit, right? And it protects the crops, especially the cotton and even wheat and your what do you call your millets can also be grown there, right? Like red or yellow soils will show a more rapid temperature rise. Dark soils will take some time to absorb the sun and release it, but if they are red and yellow, the temperature, it will immediately release the heat. Radiation happens immediately, right, with red or yellow soils. White and light colored soils, they reflect the light of the sun and do not heat up the air. So this is the reason why if you're in a desert and it is the mid-afternoon, you can see a mirage. So the reason is mainly because of the color of that soil. If the color of the soil was darker, you probably will not see the mirage. And we do not have dark colored soils in the deserts, I think, anywhere. In the hot desert, they are all light colored soils because they're just sand. The sand is nothing but quartz. And those quartz particles have got more of like white quartz than colored. There is no black quartz. So the sand is just creates that mirage, right? Next is cloud cover. So this is very interesting. So during the day, the earth is heated by the sun. So if the skies are clear, what is going to happen? The temperatures will rise, more heat reaches the earth's surface, and therefore the temperatures will rise during the day. So all the sun's heat rays are reaching the surface, right? And the surface is getting hot and releasing that heat. And so by the time it's 10 o'clock, or sometimes it's even earlier than that in the equatorial regions, then the heat is released immediately. So clear skies and it is going to be hotter. What if you have a cloudy day? So cloudy day, only some heat is reaching the earth's surface. If the ground doesn't get heated, the day is going to be cool. That is why cloudy days are cool. It's not just the shade, but it is the clouds blocking the sun's rays from reaching the land. Because only if the land gets heated up, the air around it will get heated up. Got it? So cloudy day. Now, if it's a clear night, what happens? The heat can escape immediately. As soon as the sun sets, the heat will escape. Of course, it depends on the place also. And as the heat escapes, then the night cools down. And even in the lowlands, by 1:30, you have dew. It becomes quite cold if you're sleeping on the terrace and you have to go in, right? In Bangalore, of course, nobody will even think about sleeping on the terrace because it's so like it becomes cold very quickly. But what happens if it is a cloudy night? So during the day, the ground has been heated up, the air has been heated up, and by evening, you have a cloud that comes in. Now, the cloud acts like a lid and does not allow the heat to escape further out and remains down. And therefore, you will find that we have higher temperatures at night, right? Whenever we have a cloudy night following a clear day. So clear day and a cloudy night after that, you may think, oh, clouds are there, it's going to rain, it will cool down. Only if it rains, it will cool down. But if the clouds are just there, it is just going to become worse, right? So these are some natural things. And then, of course, there are these local winds that affect temperature. Chinook winds increase temperatures of interior USA. Mistral, a cold wind in northwesterly wind in France. It actually blows down the Rhone Valley, and the valley is not very deep, so it still remains cold. If it was deeper, it would have warmed up. Loo in India, right, a hot and dry wind. These are all the common winds which are famous. And there are Booth winds that come from the Western Ghats at the height of summer, mainly for northern Maharashtra. Yeah, mainly for Maharashtra, it is not found across the country. The plateau region is higher in the south, so these Booth winds don't affect it, but the northern part of the plateau is a bit lower, and they have trap region. So then a lot of mountains and hills have got up higher than normal, and so the air comes down and increases temperature of places in the valley. mainly in central Maharashtra. They are all both winds. Right. So with that, we come to the end of. Am I going too much in detail? Are you following what I'm saying? I would like to have some feedback. Is it useful or not? Hello? Just for 6 minutes, I don't want to take another topic. Any questions? Are you able to understand? At least say yes.
Yes, ma'am.
Okay. Is it, you think it is worth it? Interesting?
Yeah, it's interesting and worth it.
Interesting. Okay. No questions. You have understood everything I said?
Yes, ma'am.
Yeah, great. Your name is Sidhu. Yes.
Questions,
Anybody
ma'am.
else? Others? Akhil?
I have some questions, ma'am.
Yes.
But I'll ask you. I'll ask you tomorrow. Ma'am.
No.
I have to revise this whole section what we are doing today.
Okay.
I'll ask you tomorrow.
Yes. Sure. Sure.
Thank you.
Yes. Veena,
Yes, ma'am.
any questions?
Ma'am, no question, but I just have a feedback that I'm feeling you are going a little bit fast.
Fast? Okay.
Yes, ma'am.
All right. So you want me to slow down?
Yeah, ma'am.
Okay.
Because
Hmm.
I'm feeling it's fast and lot of information covering it within small times.
Small time. Yes. Yes. Okay. I'll try
It's
and
unable to fetch all the details.
yeah. Actually, you should be making notes, and then, or if you have the recording with you, you can just go over it. And the idea of the session is like when you study geography, geography is not like just studying any one thing. It is like a what do you call logical reasoning that one follows the other because of this, because of that, because of that, like that. So that is why it seems like a lot of information, but actually it can be simplified, of course, a little bit. I can go slower, I guess, right? And I
Okay.
am giving you a bit more information, just to make it a little more interesting. And yeah, so yeah, I'll try and slow down a bit. Any particular area where I need to slow down? Is it the speed at which I speak?
Yes, ma'am. Speed of yours.
Actually,
Speaking.
I speak faster than this.
Yes, ma'am.
Yeah.
I think the slides goes very fast, get over very fast.
Oh, okay.
And but it's
Okay.
actually interesting, ma'am. It's very
Okay.
interesting.
Okay. Yeah. Right. I hope you're enjoying the classes. So
Yes, ma'am.
I always say that there are even I wanted to become an IAS officer, and then I got married. So that is is mainly because I feel unless you know the geography of your country, how are you going to make decisions for your country? So when I teach, that's why I teach in a different way. I don't know if your other teachers have ever taught you like this. So I teach in a different way. My approach is like starting from something simple and going to more complex, and just making you realize that you need to look at a bigger picture. You can't, like if you're a civil engineer, you can't say, oh, I'm just going to build a road here, or underpass here, and this thing. No, unless you know the slope of the land, unless you know where the water is going to come, what is going to happen during the rains. One sudden rain and everything gets flooded out, and we have landslides and so many things happening. So unless you know your geography, I feel you this basic geography, you don't even have to know any complicated stuff. And there are ways in which, like I try and show you the clues, what to look for, like from day to day, and so on and so forth. So that's why it maybe looks more complex, and maybe yeah. Always people say I teach very differently. So yeah. Okay. Thank you. Then who else here? And